Hi, today I would like to focus on linear combinations of random variables. Combinations of random variables, and that's basically in statistics 2, S2 of the A-level maths HSC. Now, when it comes to that, what I'd like to start off with is suppose you've got let y, let y is equal to, say, ax plus b, where a and b are constants. A and b are constants. Now, when that's the case, then if we want to find the expectation of y, it's going to be the expectation of, logically speaking, ax plus b. Why? Because y is basically ax plus b. So expectation of y is equal to expectation of ax plus b. But the constant, when you remove the constant out, becomes constant times the expectation of x plus the expectation of b. And expectation of b basically is b. So a expectation of x plus b. So the constant remains the same. Now, taking that idea further, suppose we want to find the variation, say the variance, I would like to find the variance of y. So the variance of y is going to be equal to the variance of ax plus b. Because the variance of y and y is basically ax plus b, so that becomes the variance of ax plus b. So the variance of ax plus b is, when you remove the constant out, the first constant is going to be a squared times the variance of x plus the variance of b. Now the variance of any constant becomes 0. So what we have is a squared variance of x plus 0, which becomes then a square variance of x. So that's the idea. So hence what we're saying basically is that if we have expectation of ax plus b, then we get a expectation of x plus b. And if you have the variance of ax plus b, basically it's a square variance of x plus 0, which is then the 0 basically. Now, in the same way, if let us suppose now you would like to find the expectation of ax minus b. Now, what is that going to be? It's going to be a, then the expectation of x minus the expectation of b. And we know that the expectation of b, of a constant, remains as it is, as a constant, minus b. But look at this very interesting aspect here. If you have variance of ax minus b, it's going to be equal to a square, of course, variance of x, but then again minus the variance of when it comes to minus, you would put it as plus the variance of minus b, so we say variance of minus b. So that becomes then a square variance of x, and plus the variance of minus b. Minus b is a constant, so plus 0. So we have a square variance of x for variance of x minus b. So what we are saying, that variance of ax minus b, I was supposed to say, is the same as the variance of ax plus b. It doesn't make any difference, because look at this here. Variance of ax plus b is a square variance of x, and variance of ax minus b instead of plus b is the same as this variance of ax plus b. So ax plus b. There we go. Now that's the introduction to the chapter of linear combination of random variables. So we're going to take some examples in the next stage of our explanation there. Now here is a very nice example based on the explanation that we just did. Okay, so given that the expectation of x is 8 and the variance of x is 2.4, and suppose we want to find the expectation and variance of the following: 3x and then 2x plus 3, 4x minus 3. So what is the expectation of 3x? Basically the expectation of 3x is going to be equal to 3 expectation of x, which is 3 times expectation of x was 8, so 3 times 8, and that's going to give us 24. So easy. Now if we want to find the variance of 3x, that's going to be 3 square variance of x, which is then 9 times the variance of x is 2.4. So 9 times 2.4 is going to give us 21.6. Now in a similar way, we want to find the expectation. So the first part is done, and for the second part I want to find the expectation of 2x plus 3. So expectation of 2x plus 3 is nothing but 2 expectation of x plus expectation of 3. So 2, the expectation of x is going to be 8, so 2 times 8. Expectation of 3 is the same as 3, the constant itself, so that's 2 times 8 is 16 plus 3, so the answer turns out to be 19. And now suppose we want to find the variance of 2x plus 3. So we know that this is going to be equal to 2 to the square variance of x, okay, plus the variance of 3. And we understand that the variance of 3 is 0, so this is 4 variance of x, so 4 times the variance of x, 4 times 2.4, and 4 times 2.4 is 9.6 basically. Okay, so now let us find the expectation for the third part of 4x minus 3. So expectation of 4x minus 3 is going to be equal to 4 expectation of x minus expectation of 3, which is then 4 times expectation of x is 8, so 4 times 8 minus 3. Expectation of 3 is the same as 3, so that's going to be 32 minus 3 turns out to be 29. And for the last part, I've got the variance of 4x minus 3. So what is the variance of 4x minus 3? It's going to be 4 square variance of x plus the variance of minus 3. This one turns out to be 0. So we got then 16 times the variance of x, so 16 times 2.4, which becomes 38.4. These are just a few examples for your understanding of linear combinations of random variables. Okay, suppose we want to take this chapter further. Now we're looking at linear combinations of 2 or more independent random variables. So basically what we mean by this is that suppose you have expectation of x plus y. You can see there's 2 different random variables. One is x and one is y. So basically it is the expectation of x plus the expectation of y, and nothing more than that. And if we want to find the variance of these 2 independent random variables, variance of x plus y is going to be equal to the variance of x, and of course plus the variance of y. And in the same manner, if I want to find the expectation of, let's say, x minus y, it's going to be expectation of x minus expectation of y. And also, if I want to find the variance of x minus y, that's going to be equal to the variance of x, okay. Minus y would mean plus the variance of negative y. So basically what we have is then the variance of x minus, okay, the variance of y would become then plus the variance of y. So this is it. Now what we can do is basically, how does this work? So if we have, let's say, let me just explain this further to you, alright? So we have variance of x minus y. So what we're saying is that this is the variance of x, and of course plus minus y in brackets. So what we are saying then is that variance of x, all right, plus, there's a minus 1 here, because minus y means minus 1 times y. So we got the minus 1 to the square times the variance of y. So we end up with, because minus 1 times minus 1 is plus 1, so plus and plus becomes plus, and I got my variance of y. So variance of y times 1 is variance of y. So variance of x minus y is basically variance of x plus variance of y. This is how we come about with this one, all right? So let us suppose now we put a constant into these random variables. So if we put a constant, I can have expectation of, let's say, ax, all right, plus by, where a and b are constant. So that's going to become a expectation of x. I'm sure you can easily make out for this one, plus b times the expectation of y. And of course, if I want now the variance of ax, big X, plus by, that's going to be equal to the a square variance of x, okay, plus b square variance of y. Okay, so this is how we go about it and try to understand how we can figure out, we're going to be using these basically to find answers to certain questions. So we can have lots of different random variables, okay. So we can just say, for instance, let u, v, w, and say further x, y, and z be independent variables. Now from here, okay, what we can do is that if we want to find expectation of, let's say, all of these variables, u plus v plus w plus, let's say, x, y, z, x, y, and then z. So what are we going to say? We're going to say expectation of u plus expectation of v plus expectation of y, w, plus expectation of x plus expectation of y plus expectation of z. Right, so this is how it works out, and this is what we have. And in a similar fashion, if I have to find the variance of, let's say, u plus v plus w plus x plus y plus z, so how are we going to do this one? So that's going to be then the variance of u, okay, independently, all right, plus the variance of v plus the variance of w plus the variance of x plus the variance of y plus the variance of z. I don't think there's anything difficult with that. Okay, so now we're going to look at an example. So we're going to try and work these out. X, y, and z are three independent random variables, I would say this, and the means of x, y, and z are 12, 14, and 18 respectively. The variances of x, y, and z are 2, 3, and 4. Find expectation of x plus y. Well, for the first part, expectation of x plus y is going to be equal to expectation of x plus expectation of y. If we do that, you got expectation of x, which is 12, expectation of y is 14, so I got then 12 plus 14, my answer would then be 26. Second part, I want to find the variance of x plus y. So basically we have the variance of x plus the variance of y. And the variance of x plus the variance of y would be then 2 plus 3, which is 5. Second answer. And for the third part, I want to find expectation of x plus y plus z. So expectation of x plus y plus z, that's going to be equal to expectation of x plus expectation of y plus expectation of z. And do that, you're going to get 12 plus 14 plus 18. So 12 plus 14 plus 18, and that turns out to be 44. So right, yeah, 44. And if I want to find for the fourth part over here, where's the fourth part? 1, 2, 3, 4. So 1, 2, 3. 1, 2, 3, fourth part, variance of x plus y plus z. So the variance of x plus y plus z is nothing more than just the variance of x plus the variance of y plus the variance of z. And you just add the numbers up. So the variances are 2, 3, and 4. So that's going to be 2 plus 3 plus 4. And you're supposed to get 9. And for the fifth part, I want to find the expectation of 3x minus y. So expectation of 3x minus y is nothing more than 3 expectation of x, okay, minus expectation of y. So 3 times expectation of x been given as, which is the mean of x, 12, so 3 times 12. Okay, minus expectation of y, and expectation of y is 14. So that's going to be 36 minus 14. So 36 minus 14 is going to be equal to 22. So that's the answer. And the sixth part, or part 6 of the question, the variance of 2x minus 2y. So what is the variance of 2x minus 2y? Would you agree with me that that's going to be 2 to the square, variance of x, and of course the minus turns into plus. So plus 2 to the square and the variance of y. So that's going to be then 4 times the variance of x is 2, plus then 4 times the variance of y is 3. So 8 plus 12, and the answer turns out to be 20. Right, and for the seventh part, expectation of 3x minus 2y minus z. So expectation of 3x minus 2y minus z. So that's going to be 3 expectation of x minus 2 expectation of y, okay, minus expectation of z. So that's going to be 3 times, so expectation of x is 2, so 3 times 2. No, hang on, 3 times 12. So I've got 3 times 12. All right, minus 2 times 14. Okay, and then minus 18. So if we were to compute that from your calculator, you should be able to get minus 10. And the last part, okay, I'm sorry about the barking of the dog in the background. That's from my neighbor anyway. We don't actually keep a dog in the house. So what is the variance of 3x minus 2y plus z? So the variance of 3x minus 2y plus z is going to be 3 to the square, variance of x, minus turns into plus, plus 2 square, variance of y, okay, then plus the variance of z. So we are saying 9 times the expectation, variance of x, which is 2, so 9 times 2, plus 4 times 3, okay, plus 4. So that's going to be 18 plus 12 plus 4, which is then 34. So this is our answer. Well, I hope that has given you some understanding of how we look at linear combinations of random variables. The next part of the chapter would be then linear combination of 2 or more independent observations of the same random variables. Okay, take care.